Good morning.
Good morning. What's all this? Your results. Congratulations to all. I am confident you'll all achieve your goals. So young man, what are your aspirations?
I want to do robotics, ideally from the Bust Institute in the US.
And you, young lady?
Sir, I love kids and I would love to learn pediatrics. I feel Boston is the best place for that.
Sumit, what about you?
Back home to India for medicine.
Good. I'm sure you'll all achieve your aspirations, be it in India or anywhere. Keep in mind, your first challenge is the entrance, whether it's IIT, JEE, SAT or NEET. You have to learn from the masters. Brilliant Qatar is the passport to your success.
We undertake coaching for regular and repeat batches and tuition for board examinations. Brilliant Education Centre, Doha, Qatar.
Good evening, dear students. How are you all doing? So we are into the final lap of our revision classes. So in the last live, we had done an overall topic discussion. So we will be continuing that discussion and we'll go through some more important questions along with MND quiz. Right. So we'll start right away. I hope my sound is crisp and clear to everyone. Can you please comment in the chat box? Am I audible to everyone? Yes. Okay, perfect. So let's continue the discussion. Let's go to the next question. So you can see here in the next question, study the experimental setup shown in figure and choose the correct option from the following. So here we have an apparatus, and in that apparatus you can see that there is a tube in which dilute hydrochloric acid is taken. And in another tube, they have calcium hydroxide solution, and we have a substance P which is in the mixture along with hydrochloric acid, and then they are pointing to a substance Q which could be a gas. So from the table, the given options, what will be the right choice? See, it's a very easy question. You can easily see that there is calcium hydroxide solution given here, right? Calcium hydroxide solution is called as lime water. So if lime water is there as a qualitative assessment part, then we know that it will be the test for carbon dioxide. So we can assume that the gas which is produced here will be carbon dioxide. And then there is dilute hydrochloric acid and you are adding a substance P to it. So you have studied in the chapter acids, bases and salts that when any metal carbonate or bicarbonate is added to a mineral acid or an organic acid, it will form salt, water and carbon dioxide, correct? So the substance that is indicated as P here will be most likely a metal carbonate or a bicarbonate. So let us go through the options. I can see that most of you have already answered. It's option D. Why is it option D? Okay. So in that substance P is written K2CO3. Yeah, that's correct because it's a metal carbonate. Potassium carbonate is a metal carbonate. And then we have Q given as carbon dioxide gas. Yes, that is true because this carbon dioxide gas, when it comes through this tube, is going to enter into lime water. And what will happen to lime water? We know that lime water is calcium hydroxide, and when carbon dioxide is passed into it, it will become calcium carbonate plus water. And calcium carbonate is not soluble in water, so it will impart a cloudy appearance or a milky white appearance to the solution, right? So if lime water turns milky, it's an indication that the gas passed is carbon dioxide. Yes. Yes, excellent, Rahul. Acid plus metal carbonate gives salt plus water plus carbon dioxide. It can be metal carbonate or metal bicarbonate, okay? Right. So I hope this question is clear to all of you. Okay, excellent. Right. Now, the next question. So for the previous question, the answer is D. So everybody understood that question clearly. This is one of the frequently asked question in board examination. So you have to be thorough with that particular reaction. Metal carbonate or metal bicarbonate is going to give you salt plus water plus carbon dioxide. Okay, excellent. Next one. Consider these indices of refraction. Glass 1.52, air 1.0003, water 1.333. Based on the refractive indices of these three materials, arrange the speed of light through them in the decreasing order. So we have studied in the last class also, I told you, the questions related to refractive index is a very important area where you need to focus. So refractive index of any material is inversely proportional to the speed of light in that material, correct? So we know that if the refractive index is too high or if it is large, the speed of light will be minimum, correct? So here they say refractive index of glass is 1.52. Then refractive index of air is 1.0003 and refractive index of water is 1.333. So we have to arrange the speed of light through them in the decreasing order, right? So from higher to lower. So in which medium light will be traveling faster? The light will be traveling faster in air, which has the least refractive index. And then we have the next higher refractive index is for water. So velocity of light in water is going to be lesser than in air. And then finally, we have velocity of light in glass, which will be the least because glass has got the higher refractive index value, right? Yes. So what will be the right choice? Speed of light in air is greater than speed of light in water is greater than speed of light in glass. So C option seems correct. So it's a very important question. It's a very important area. Most probably you're going to get a question related to refractive index this year as well. So you have to be confident in that. Right. So I hope this question is also clear to all of you. Okay. Okay, kids. Right. The next one. In peas, a pure tall plant is crossed with a short plant. The ratio of pure tall plants to short plants in the F2 is, see, heredity and evolution. In that chapter, you know that evolution topic is deleted and all you have is heredity and mainly the Mendelian crosses and also sex determination. These are the two main topics that you have to learn in that chapter. And it is a very important chapter where you can have so many conceptual questions coming. Especially from the Mendelian crosses part, you have to have a crystal clear idea about how Mendel conducted the crosses, what were the interpretations that he got, what are the laws of inheritance that he formulated. Everything should be very clear to every one of you. So in this question they say a pure tall pea plant. So a pure tall means it is homozygous. Homozygous means what? If an individual has a particular character and if it has only the alleles for that particular character, that is called as homozygous or pure individuals, right? So a pure tall individual can be written like this, and it is crossed with a short plant. So a short plant can be indicated as small t, right? So when we when we cross these two individuals, you know that this individual is going to produce one type of gamete only, and that is capital T, and this individual is going to produce one type of gamete, that is small t. And we are going to see capital T, small t as the genotypic constitution of that particular generation, which is obtained from the first cross, and that is called as the F1 or the first filial generation, right? And this is where the Mendelian law of dominance was formulated, correct? What is Mendelian law of dominance? It says when an individual have two different types of factors coming together for a character, only one factor is expressed in the outside. One factor is visible outside, whereas the other factor is suppressed. And the suppressed factor is called the recessive factor, and the expressed factor is called as the dominant factor. So here, this individual is going to be tall when you look at from outside, right? So it is phenotypically tall, but it is genotypically having both the genes, that is having the gene for tallness as well as the gene for dwarfness, right? Now they are asking the generation in the F2. So you know that F2 is obtained by selfing of the F1 individuals, right? So F1 into F1. So we will see a cross where capital T, small t is crossed with capital T, small t again. So this individual is going to produce two types of gametes, capital T and small t, and here also capital T and small t. And in the F2 generation, the individuals that you can get can be illustrated by a Punnett square, or you know, by simply showing the gametic combinations here. Capital T, which is going to be tall. Then we have capital T, small t, which is again going to be tall. Then again we have capital T, small t, which is also tall. And then the last one is capital small t, which is going to be short. So we have 3:1 as the ratio of the phenotypes. Means what we externally see is 3 tall and 1 short. But what is asked in the question says the ratio of pure tall and pure short is how much? Pure tall is only this, and pure short is only this. What is their ratio? 1 out of 4 is pure tall, and 1 out of 4 is pure short. So what is the ratio? It is 1:1. This ratio related questions are very, very, very important in board examination, because they can give you for any character based on dominant and recessive interaction. Clear? And you must remember that in 10th standard you are studying certain clauses and you are learning the law of dominance and all, but law of dominance is not true in all the cases. You know, Mendel has proposed total 3 laws, right? What are they? The law of dominance, the law of segregation, and the law of independent assortment. The law of independent assortment was proposed based on the dihybrid clause. You know, among these 3 laws, there is only one law that has no exception at all. Can you say which law is that? The only law of Mendel which had no exceptions. I'll tell you a hint. That law is also known as the law of purity of gametes. That law is also known as the law of purity of gametes. Come on, which law is that? Yes, which law is that? The law of purity of gametes. Yes, very good, Harun. Very good, Fatima. It's the law of segregation. The law of segregation is also known as law of purity of gametes. You know why it is called so? Imagine this individual, capital T, small t. This individual have 2 types of factors in it, right? So we can say that that individual is not pure. But when that individual forms gametes, each factor will segregate into individual gametes, right? Such that each gamete has only one factor for a character. That means if you consider the gamete alone, you can see that it is having only one at a time, only one factor at a time. That is why it is called as law of purity of gametes. The gametes are always pure. The gametes are always pure. Is this clear? And that law is the only law of Mendel which did not have any exceptions till date. But law of dominance have exceptions like incomplete dominance, codominance, etc. Law of independent assortment has exceptions like linkage, crossing over. The various phenomena was observed. But law of segregation does not have any kind of exceptions. Right. So that is option C. Okay. Let's move on to the next question. Match the terms of column A with this of column B. So here we have a list of receptors in our body. From the chapter Control and Coordination, a very important concept, a very important area. This is quite easy for you. You guys know the name of different receptors. We have olfactory receptors. Olfaction means what? Olfaction is smell. Smell is through nose. Then we have thermoreceptors. Thermoreceptors are for sensing heat, and that is present on our epidermis or the skin. Then we have gustatory receptors. Gustation is actually taste, so it is through the tongue. And then we have photoreceptors, which is present in the eye. So that is on the retina, we have the photoreceptors present. So these are different types of receptors that we have in our body. Clear? Gustatory receptors. About gustatory receptors, there is an important point I want to mention. When you are writing in board exam, make sure the spelling is correct. If you write gustation like this, the whole idea is changed. Gustation actually refers to the pregnancy period. Is it clear? Right. So what is the right choice? So A is 3, B is 4, C is 1. So it's option A itself. Right. It's clear, right? Okay. Next one. Which one of the following structures correctly depicts the compound calcium chloride? Calcium chloride, as you know, it is an ionic compound. Ionic compounds are formed by metal and non-metal combination, right? So whenever you get a compound whose electron dot structure has to be identified or drawn, first thing you need to know is their atomic number and the electronic configuration. Calcium, for example, it is atomic number 20. So its configuration is going to be 2882. And chlorine is atomic number 17. So its configuration is going to be 287. So by looking at the valence electron of calcium, we understand that it has 2 electrons, so it's going to lose 2 electrons. And by looking at chlorine's condition, we know that chlorine requires only 1 more electron to complete octet, so it is going to gain 1 electron. So calcium is going to lose 2 electrons and chlorine is going to gain 1 electron. So if we have to draw the electron dot structure, calcium has total 2 valence electrons, and it is going to donate these electrons into chlorine atom, because one chlorine atom cannot form a ionic bond with calcium, because one chlorine can accept only 1 electron. So you need total 2 chlorine atoms, and into each chlorine 1 electron from calcium goes, and calcium is going to become positively charged. And how many positive charges will be there? There will be 2 positive charges, right? Calcium ion. And then we have chlorine, which has got now octet in its outer shell, right? So it is going to have 1 negative charge, but remember there are 2 such chlorine. So it's going to be calcium chloride, CaCl2. So which option is correct? Is it clear to all? The idea of drawing the electron dot structure? Okay. So here in the options, calcium with the 2 positive charge and chlorine with 8 electrons and 1 negative charge, and 2 of them fits best for option C. Right, option C. Okay. Now, let's move on to the next question. So for this question, I'll give you some time to read. This is a very, very important question from the chapter Light. So examine the given figure and state which of the following option is correct. One small box in the figure is equal to 1 centimeter. I'll zoom the diagram a little bit. I hope it is clear to everyone now. Yes. Try to answer. Each box is corresponding to 1 centimeter. Yes, Rahul, the tango receptors are again actually the receptors present on the skin. They are responding to touch and pressure. Those are the receptors which are called as tango receptors, right? Okay, so many of you are saying the answer is option B. Okay, let's check. See, from the diagram, it's very evident that it's a concave mirror. So for a concave mirror, its focus will be lying in front of it. So if this is 1 centimeter, this will be 2, this will be 3. So from this, it's very clear that the focal length of that mirror is going to be minus 3 centimeter, isn't it? Because in the Cartesian coordinate system, the focus lies on the left side. So it is minus 3 centimeter. So what will be the point here? This is center of curvature, right? So here it will be 6 centimeter, right? And you can see the object is kept here at the C. So for a concave mirror, you know that if you keep the object at the center of curvature, the image will also be formed at the center of curvature. It will be a real inverted image having the same size of the object, right? The image will be having the same size of the object. So in that case, what will be the value of your magnification? Magnification will be 1. And since it is a real image, the magnification is going to be -1. So which option best fits for that? All of you are saying B, some are saying C. Why C? See, the problem with option C is the mirror has a focal length of -3 and will produce an image of magnification +1. That is the issue. You see, focal length is correct. It is -3. But it doesn't produce a magnification of +1 because this is a real image, right? So in a real image, the magnification value is going to be negative. Is it clear to all? Yes. See, that you can easily understand by simply looking at the magnification equation HI by HO. If it is a real image, you know that the image will be inverted, right? So that will be negative and the object is kept upright. So it will be positive. So the magnification will be negative for all the real images. Is it clear? Fatima, Rishi, Mridul, Abhinav, is this point clear to all of you? So the right choice will be the mirror has a focal length of -3 centimeter and will produce a image of magnification -1. Yes, perfect. Okay. So it's a very easy question, but at the same time, a very important concept. Okay, I believe all of you are thorough with all the sign conventions that you use in the mirrors and lenses, right? Okay. Let's move on to the next question. Which of the following salts do not have water of crystallization? What is water of crystallization, first of all? You know, the definition of water of crystallization is, it is the fixed number of water molecules that is present in one formula unit of a salt, right? There are some salts like that. For example, if you take copper sulfate, CuSO4, in one formula unit, that is 1 CuSO4, there will be 5 units of water present in it. So the formula of the crystallized form of copper sulfate is CuSO4.5H2O or copper sulfate pentahydrate. Like that, there are plenty of salts. So first they have given bleaching powder. You know that bleaching powder is calcium oxychloride. It doesn't have any water of crystallization. Then plaster of Paris. What is plaster of Paris? Calcium sulfate hemihydrate. CaSO4.5H2O. This has water of crystallization. Then we have washing soda. Washing soda is Na2CO3.10H2O. Sodium carbonate decahydrate. Then we have baking soda. Baking soda is NaHCO3, sodium hydrogen carbonate. It doesn't have water of crystallization. So only plaster of Paris and washing soda have water of crystallization. The question is, which of the following do not have water of crystallization? So bleaching powder and baking soda, 1 and 4, do not have water of crystallization. Is it clear to all? Okay, perfect. Yes, very good. Very good. 1 and 4 is the right answer. Shall we move on to the next question? This is clear to all of you? Right. The next one. A student learns that magnetic field strength around a bar magnet is different at every point. Which diagram shows the correct magnetic field lines around a bar magnet? Come on. You know that magnetic field lines around a bar magnet and a solenoid are forming closed loops, isn't it? So which of the diagram shows the correct explanation or the correct depiction of the magnetic field lines? You know, in a bar magnet, the magnetic field lines start from the north and it ends at the south pole. And then inside the magnet, it moves from the south to north. So which diagram is perfectly depicting it? Yes, all of you are familiar with this diagram from the textbook. It is option B. Magnetic field lines forms closed loops. Right. Okay, great, great. Everyone is answering confidently. Option B. Okay, perfect. Right. So I think we can move on to the next question. What is the direction of magnetic field at a point A above the wire carrying current I as shown in the figure? Yes. Finding the direction of magnetic field. Come on. Which rule are you going to use here? Which rule are you going to use here? Yeah, which rule are you going to use here? Yes, the right hand thumb rule or the Maxwell's corkscrew rule, isn't it? So when you hold the wire in your right hand in such a way that the current is pointing, the thumb is pointing towards the direction of the current, then the fingers that wrap around will show you the magnetic field, correct? So in this picture, you can see that the current is moving in this direction. So if I hold my thumb towards the direction of the current, I can see that my fingers that wrap around is coming up like this towards me or towards you at the point A. And if the point was mentioned below, it seems like it's going inside. So at the point above the wire, it seems like it's coming towards you, and at the point below the wire, like a point B, it seems like it's going inside. I hope everyone is clear with this idea. So what is the direction of the magnetic field here? Yes, yes, yes. All of you have answered A. Okay, perfect. Out of the page. Out of the page. Okay, great. So we can use right hand thumb rule for finding the direction of the magnetic field around a current carrying conductor. Then we have Fleming's left hand rule, right? What is it used for? It is used to find the motion or force exerted on a current carrying conductor which is kept in a magnetic field, right? Then we have Fleming's right hand rule, which is of not much significance this year. So you have mainly the right hand thumb rule and the Fleming's left hand rule. Right. Right. Okay, great. So let's move on to the next question. A zygote which has an X chromosome inherited from the father will develop into a. See, from sex determination, for sure you are going to get a question. That's guaranteed. You will get a question from sex determination. So here the question is a zygote which has an X chromosome inherited from the father. You know that in human beings, the males are heterogametic. What does that mean? Males have 44 autosomes and XY chromosomes. And the females are homogametic. Female has 44 autosomes and 2 copies of X chromosome. So if you look into the gametes of a male, the sperms that the male produce, sperm 1 and sperm 2, will be of two types. One will be having autosomes plus an X chromosome, and one will be having autosomes plus a Y chromosome. Whereas a female is able to produce only one single type of ovum. Right? Only one single type of ovum, I said. So there will be 22 autosomes and an X chromosome. So the female is always, or the maternal side, from the maternal side, we are always getting the X chromosome. So it's the father or the paternal side is going to decide the sex of the baby. So if the sperm containing X chromosome is fusing with the ovum, you will get 44A plus XX, and that's going to be a girl child, right? And if it is a Y chromosome containing sperm that is going to fuse with the ovum, you get 44A plus XY, that will be a boy. So here the question is, a zygote which has an X chromosome inherited from the father. So father has given X, mother will be giving X, so those two X combines to form the female, right? So it's going to be a girl in this combination. Is it clear? Yes, and I believe you are very clear about the term what is heterogametic and what is homogametic. Heterogametic means an individual who is capable of producing different types of gametes. See, in terms of the genetic constitution, I'm saying, for example, human males are heterogametic, whereas human females are homogametic because a human female will produce only one kind of ovum. All the ovum will have the same kind of genetic constitution. Is it clear? See, I'm not saying about the gene combinations, I'm talking about the chromosomal constitution. Right. So this question is clear. Shall we move on to the next? Okay, great. The next question. Na plus has, Na plus, you know, it's an ion, right? Positively charged ions are called as cations. So if they ask you the constitution of ions, it should be very easy for you to answer, because you know that an element, for example, sodium as an element, if you take, its atomic number is 11. What is the meaning of that? It has 11 protons and 11 electrons, right? That is called sodium element, or sodium as an atom. Now, what is Na plus? Na plus means sodium atom who has lost an electron, right? Because if an element loses electron, the number of protons will be more, right? Think like this. If sodium is losing one electron, the number of protons is still 11, but you know the number of proton is now 10. So there are 11 positive charge and 10 negative charge. So there will be one extra positive charge remaining in that species, right? So this is called as a cation. And on the other side, we have anions. What are anions? Anions are those where gain of electrons has happened. That means the number of electrons in that species is more than the number of protons, right? So here the question is, sodium ion contains how many protons and how many electrons? There will be 11 protons and 10 electrons only. Yes, negatively charged ions are called as anions. Negatively charged ions are called anions. In their name itself it is there, isn't it? What is an anion? In their name itself it is there. A negative ion, isn't it? This is not real, okay? I just made it up. A negative ion. So you will not have a confusion with cation and anion anymore. Cation is positive and anion is negative. Is it clear to all? Okay, perfect. Okay, look into the next question. A metal rod, PQ, is placed in the magnetic field. The ends of the rod is connected with a battery using wires. Where will the rod move? where will the rod move? Here, I'll just zoom into the picture a little bit so that you can apply the rule properly. Here we are going to find the direction of the force experienced by the rod PQ. So how do you work it out? Here we know that the current will be flowing in this direction, from positive to negative. So this will be the direction of the current, right? This will be the direction of the current. And then magnetic field. Magnetic field is acting in the upward direction. So this is the direction of the field. So which rule are you going to apply here? You can apply Fleming's left-hand rule, right? Fleming's left-hand rule. So in left-hand rule, what do? We hold our thumb, middle finger, and the forefinger in mutually perpendicular direction, right? In mutually perpendicular direction. And then what do? You hold the middle finger in the direction of the current, the forefinger in the direction of the magnetic field, and then look at where is your thumb pointing. See, when I hold it in this pattern, I can see that the thumb is pointing towards me, right? That means it's coming out of the screen, right? So all of you are able to find it out by holding your left hand in that direction, as I said, forefinger for field, middle finger for current, and the thumb is indicating the direction of the force experienced. So where will be the force experienced, or where will be the rod moving? The rod will be pushed out of the page. The rod will be pushed out of the page. Right, perfect. Yes, now all are answering D. Okay, great. The rule is clear to everyone, right? And the application is also clear. So here if you reverse the direction of the current, the direction of the force will also reverse. Here if you reverse the direction of the field, again the direction of the force will reverse. So we use this Fleming's left-hand rule as a simple aid to find out the direction in which the motion is experienced on a conductor which carries current kept in a magnetic field. Right. Okay, great. Now the next question. For a current in a long straight solenoid, north and south poles are created at the two ends. Among the following statement, the incorrect statement is a current carrying solenoid. Very important. You know that it can be used as an electromagnet. You keep a soft iron inside this solenoid coil, you can make it magnetized, right? So what are the statements given here, and you have to pick the incorrect statement. Let's read the statements. The first statement says, the field lines inside the solenoid are in the form of straight lines which indicate that magnetic field is same at all points in the solenoid. That is a true statement, correct? Because a current carrying solenoid's magnetic field is identical to a bar magnet, right? Inside it is moving from south to north, and it is all in straight lines. Outside it is forming closed loops. So that statement is correct. And then the second statement, the strong magnetic field produced inside the solenoid can be used to magnetize a piece of magnetic material when soft iron is placed inside the coil. That is also true. You can make electromagnets out of solenoids. Then the third statement, the pattern of magnetic field associated with a solenoid is different from the pattern of magnetic field around a bar magnet. No, they are exactly the same, isn't it? Is current carrying solenoid's magnetic field is very much identical to that of a bar magnet. So that statement is not true. Let's read option D as well. The north and south poles exchange positions when the direction of current through the solenoid is reversed. That's true. We know that when the direction of the current is reversed, the direction of magnetic field also changes. So that is also a correct statement. So the only incorrect statement about the solenoid is option C. Okay, great. Yes. Shahyan is so confident about C that he mentioned C a lot of times. Okay, very good. Keep it up. Let's move on to the next question. The graph given below depicts a neutralization reaction. Acid plus alkali gives salt plus water. The pH of a solution changes as we add excess of acid to an alkali. Which letter denotes the area of the graph where both acid and salt are present? One of the most important chemical property that you have learned in acids, bases, salts chapter is the neutralization reaction, right? When the effect of an acid is nullified or cancelled out by a base, it's called as neutralization. So they say the pH of the solution changes as we add excess of acid to an alkali. So initially you can see the graph starts at 14, which means there is an alkali present, and when you keep on adding acid, what will happen? The alkalis OH minus will be cancelled out by the H plus added by the acid. So it keeps on cancelling it out, and at this point you will achieve neutralization, right? Because that's the point where the pH is 7. So at this point, we have salt present, and then if you keep on adding acid to it, what will happen? Salt will be there, and the extra added acid will be staying in the solution as it is. So the segment of the graph below 7, this area will be the area where you will have both salt and acid present. So the option is going to be D. The segment of the graph where both acid and salt are present is option D. Is it clear to all? Yeah, above 7 in that zone, predominant molecule is the base itself or the alkali itself. And when you reach 7, that's the time where the alkali gets completely neutralized by acid. And then if you keep on adding more and more acid, what will happen? You're just increasing the amount of acid in the solution, that's it. But still, nothing happens to your salt. The salt is still in the solution, and you're adding more and more acid to it. So the pH is going to come down. Right. Option D. Okay, great. The next question. The IV characteristic of copper wire of length L and area of cross-section A is shown in figure. The slope of the curve becomes. It's a question from electricity, and it's a very, very, very important question. I wanted to include this question because, many a times students make a mistake in this segment, not because they don't know the concept, just because of the carelessness. And the carelessness is mainly going to be in this graph. You see this graph. This graph is a I versus V graph. It's not a V versus I graph like what you see in Ohm's law. You guys know that V is equal to IR. This is the equation for Ohm's law. So if you take the voltage in the y-axis and current in the x-axis and you plot a graph between both of them, V versus I, then we get a straight line where the slope of the graph is going to be, the slope M of M is going to be the resistance, right? But here in this graph there is a small difference. What is the difference? This is a I versus V graph. Are you understanding that? It's an I versus V graph. So we have to think the other way. Look at this. I is equal to, I can write V by R, or I'll just write V into 1 by R. I hope it is clear to all of you. This equation is clear to all of you. And how did I plot the graph? I took I in the y-axis and the voltage in the x-axis. And then what is the slope of the graph? The slope of the graph is 1 by R. The slope of the graph is 1 by R. It is not R. It is not resistance. It is 1 by R. Are you understanding what I'm saying? So what is the meaning of that? If this graph has a bigger slope or more slope, the resistance is going to be small. Is that clear? Is that clear? So now you read the options. The first option says the slope of the curve becomes less. The slope becomes less if the length of the wire is increased. We can check that. We know that resistance is equal to rho L by A, isn't it? We know resistance of a conductor is directly proportional to the length. So if the length is increased, the resistance is going to increase. If the length is increased, the resistance is going to increase. So now you read this. The slope of the curve becomes less if the length of the wire is increased. We will check that. If the length is increased, the resistance is going to increase. If the resistance is going to increase, what will happen to the slope? The slope will become lesser, or the slope will become lesser and lesser, right? Have you understood that clearly? So what do you think about option A? Option A says the slope of the curve becomes less if the length of the wire is increased. That is true. If you increase the length of the wire, the resistance is going to increase. If the resistance is going to increase, the slope of the graph will obviously be lesser. But remember, this is for I versus V graph. Is that clear? Is that clear? So less if the length of the wire is increased. Is that clear to everyone? So the take from this question is not to find the answer of this question. I want you to clearly understand that if a question based on the graph comes, look at the coordinates first. Is it V versus I, or is it I versus V? That is very, very important, and this is one common error that many students commit during the exam. And I don't want you to do that in this exam, because definitely you're going to get a question related to the graphs of V and I. Understood? Okay, perfect. Next one. Study the following table and choose the correct option. So we have a set of salts given: parent acid, parent base, and nature of salt. See, again, one of the most important area where you need to focus in acids, bases, and salts is the salts formula, and from that, how do you understand which acid and which base combination give you this salt, particular salt. Look at this, sodium chloride. Sodium chloride is NaCl, right? So in NaCl, the cation is Na plus and anion is Cl minus. So in order to find the acid and the base, the simple idea is just add OH minus to the cation and add H plus to the anion. That's it. So NaCl is a combination of NaOH and HCl. And you know that NaOH is a strong acid, strong base, and HCl is a strong acid. So the combination of this is gonna be a neutral salt, right? So option A says sodium chloride, parent acid is HCl, parent base is NaOH. The nature of the salt is basic. That is false, because sodium chloride is a neutral salt. Its pH is going to be 7, right? And then we have sodium carbonate. Sodium carbonate formula is Na2CO3. So here the anion and cation are, and cation is Na plus and anion is CO3 2 minus. So you add OH minus here and H plus here. What do you get? The base is NaOH and the acid is H2CO3. Is this clear? So NaOH is a strong base and H2CO3 is a weak acid. So strong base, weak acid. What is the combination? It's going to be a basic salt. It's going to be a basic salt. Is that clear? So this option is also wrong because it says neutral. Then sodium sulfate, sulfuric acid and sodium hydroxide. That is correct, but it's written acidic. That's false because this is strong acid, this is strong base. So it should be a neutral salt. And finally, sodium acetate, CH3COH, NaOH, basic. That is correct, right? CH3COH is a weak acid and sodium hydroxide is a strong base. So it is going to be a basic salt, sodium acetate. So that is the correctly given option. Is it clear to all? Right. So let's move on to the next question. This should be easy for you. We just discussed about the sex determination question. So quickly tell me the answer. Let me see who will post the answer really fast. Two individuals are as shown using geometric shapes. Their sex chromosomes are respectively denoted as XF, XM, and Y. What are the possible combination of sex chromosomes for their male and female offspring respectively? Come on, come on. Quick. So XFY and XMM. This is the combination. So this male is going to produce a sperm of XF and Y, and female is going to produce only one kind of sperm, and that is, one kind of ovum, and that is XM. So the combinations will be XF, XM, right? And this combination, XM, Y. So which is the right choice? Okay, I can see majority of given the right answer, XMY and XMF. Okay, perfect. XMXF. So you are confident in sex determination related questions. Okay, perfect. Shall we move on to the next? This is clear to all? Okay, great. Okay, quickly, the next question. In the following circuit, heat produced in the resistor or combination of resistors connected to a 12-volt battery will be. Here there are three combinations given here. Three combinations. In that, heat produced will be maximum in, or minimum, or is it same? So there is an easy way to look at this question. First of all, you just look at the resistances. Here the resistance is 2 ohm. Here the resistance is going to be 4 ohm, correct? Because it's a series combination. Here the resistance is going to be 1 ohm. So the total resistances in each case is very clear. 2, 4, 1. And the voltage is all same. It's 12 volt. So we know that heat produced is equal to V square by R into T, right? So you can apply this equation here, because here the voltage is constant, and assuming the time for which the current is moving through the conductor is also constant. So heat produced will be inversely proportional to resistance. What does that mean? Lower the resistance, higher the heat, or vice versa. Higher the resistance, lower the heat. You don't have to calculate exactly how much is the heat produced here, because this is very simple circuit. You have 12 volt voltage applied in every circuit, and the resistances are all different. So just look at how is the heat and the resistance related, because it's all going to have the same voltage. So tell me, where the resistance is low, the heat will be higher. So maximum heat will be produced in the third circuit, right? So first option, same in all three cases, that's wrong. Minimum in case 1, no. Maximum in case 2, that's wrong. Maximum in case 3, that is correct, because here in case 3, you have the least resistance. Least resistance, higher the heat produced. Is it clear? Don't waste your time sitting and calculating the amount of heat produced here in each case, okay? You can do that by using power equal to V into I, or I square RT, or heat is equal to VIT, or I square RT, or V square by RT. You will get the values, but it's of no use. It's an MCQ question. You need to save as much time as possible. Clear for all? Okay, great. Come on, quickly. The next question, answer. 5 solutions are labeled on a pH scale. You have A, B, C, D, E. Which classification is correct? Come on, fast. Which classification is correct? See, from the pH scale itself, we can see that A is going to be the most acidic and E is going to be the most basic. So in option A itself, it is clearly given strongest acid is A and strongest base is E. So it is the correct choice. Okay, perfect. Most of you are answering the question correctly. Okay, excellent. Okay, great. In that case, we'll move on to the next question quickly. Bulbs B1 and B2 are exactly identical. When the key K is pressed, the reading of the ammeter will be. Come on, I want you to use your logic here, quickly. Let me see who is going to answer fast. Bulbs B1 and B2 are exactly identical. When the key K is pressed, the reading of the ammeter will be. Look here, you can simply imagine it like this. if the bulb B1 and B2 are identical, that means they have the same resistance, right? So let us assume that this has a resistance of 10 ohm and this battery has a voltage of 10 volt. Okay, initially when the key is not pressed, who only is there in the circuit? You have only bulb B1. In that case, what will be the current flowing through this ammeter? It will be V by R, which is equal to 10 by 10, it is equal to 1 ampere, correct? Now, I am closing the key means I am including this bulb also in the circuit, correct? So I have now two bulbs of identical resistance which are connected in parallel. What is the total resistance combination of this? This is going to be 5 ohm now because it is a parallel combination, right? It is a parallel combination. So if it is a parallel combination, the total resistance of two identical bulbs with 10 ohm each, the net resistance will be 5. So what will be the total current flowing through this now? I is equal to V by the total resistance is going to be 10 divided by 5, that is 2. So when the first bulb was there, there is 1 ampere current flowing. Now when the second bulb is there, there is 2 ampere current flowing. So what is the right choice? Yes, Mridul. Very good. Yes, Rahul. Excellent. So when the key K is pressed, you are adding one more resistance in parallel. So that is going to double the current flowing through that ammeter. Is it clear? Yes, Abhinav. Anna, great. Okay. The next question. The reaction between iron oxide and hydrogen is given below. Which option shows the compound undergoing oxidation and reduction? Tell me, Fe3O4 and H2 giving Fe plus H2O. Who is undergoing oxidation? You can see that H2 is becoming H2O. This is oxidation. And Fe3O4 losing oxygen. This is reduction. So we can say H2 is undergoing oxidation and Fe3O4 is undergoing reduction. And you also know how to identify the reducing agent and oxidizing agent. Who is the oxidizing agent here? Oxidizing agent is the substance which gets reduced, isn't it? So Fe3O4 is the oxidizing agent and H2 is the reducing agent. So it's option A. Is it clear to all? Okay, right. Next one. Anita added a drop each of diluted acetic acid and diluted hydrochloric acid on pH paper and compared the colors. This was actually from the last test. Some of you had doubts in those questions. So I'm just explaining those questions. Which of the following is the correct conclusion? So here acetic acid and hydrochloric acid. You know that acetic acid is a weak acid and hydrochloric acid is a strong acid. Strong acid will produce more H plus and it will have lower pH. And weak acid will produce less H plus and it will have higher pH. So we can say pH of acetic acid is going to be more than that of hydrochloric acid. Is it clear, guys? pH of acetic acid is why? I can see some of you are still making the mistake there. Acetic acid is a weak acid, so it will have less H plus ions. Less H plus, more pH. More H plus, less pH. Got it? Okay, perfect. The next one. In the given transverse section of the leaf, identify the layer of cells where maximum photosynthesis occurs. You know that photosynthesis takes place maximum in the mesophyll cells, right? So in this picture, mesophyll cells are marked in this zone. So it is 2 and 3. That is where the mesophyll cells are present. Okay, great. The next one, if a tall pea plant is crossed with a pure dwarf pea plant, tall pea plant is crossed with a pure dwarf pea plant, what percentage of F1 and F2 are respectively tall? You know that in the F1, all of them are capital T, small t, tall. So 100% is tall in the F1, and in the F2, how many were tall? 3:1, right? 3:1 means 3 out of 4 were tall. That means 75% is tall. So 175 will be the answer. 175 will be the answer. Will this year's exam be easy or tough? It's definitely going to be easy. Tushara, don't worry about it. It's going to be easy. You are ready for it. Okay. A student placed 10 ml HCl and NaOH in two separate beakers as shown. In the beaker 1, 4 ml of NaOH is added. Beaker 2, 4 ml of HCl is added. Student notes the possible change. See, in this HCl beaker, if you add NaOH, what will happen to the pH? The pH is going to increase. And if you add HCl into this beaker, the pH is going to decrease. So, increase in beaker 1, decrease in beaker 2. Option C is the right choice. Is this clear? Okay, the last question. Given below are the reactions involving metal P, Q, R and S and their salt solutions in water. Metal P salt solution plus Q giving metal Q salt solution plus P. What is the inference from this? If Q is able to displace P, Q is more reactive than P. Then Q salt plus R gives metal R. That means here R is greater than Q, means reactivity. Then S plus Q, here Q is greater than S. And metal P plus S, there is no reaction. What does that mean? P is more reactive than S. Here the question is, who is the most reactive element? The most reactive will be definitely R, because it can displace even Q also, which can displace P as well as S. So the most reactive element is going to be R. So I hope these questions are clear to every one of you. This was from the last mentee, and today we have a mentee. Do you want the mentee now, or do you want a break? Okay. So just a second, we'll be starting the mentee in a while. So as I said, this is towards the last lap of revision that we are doing for the board exam. I hope everyone is ready to appear for the board examination. Do not think that you are an average student. I have seen some of the comments like that. You are an average student, or I can't do this, I can't do that. I told you in every class, in every live when I came, I told you the only thing that you have to do is believe in yourself. Understand that the exam is going to be easy if you are approaching the subject and the revision with a positive mindset. So please do have that mindset, and then practice from home as many questions as possible. And all the live sessions that we have done in the past weeks, it is already there in the YouTube. Go through it, do practice the MCQs once again, and develop that confidence. You can do it, and you will be able to score really good marks. I think our time does not allow the session for a mentee today, so I think we may have to skip this session. You all can take a break now. We will be continuing the next live session. So that time, if possible, we can do the mentee as well. Right. So see you all. Prepare well. If you have any doubts, all your teachers are available. You can clear all the doubts and stay confident. We can crack this exam with wonderful marks. All the best, dears.